So welcome to our third and final part of the loot box, where we're going to open the loot box from inventory. And so before we show you the end product, let's take a quick look at how the flow of the code will look. So our high level design for this, and I think we've discussed a little bit in other videos, is it sort of starts on the client where I choose to double click an inventory item. Now, when we're looking at the inventory grid, our items are being presented in a list object, which has an event double click on. So we will be double clicking the list object in a single select mode, which will perform this double click, which will kick off the process. At that point, the client will ask the server to run the math on the probabilities of getting things in the loot box, which we perform on the server. We then populate a data structure and replicate that data structure back to the client, where the client picks up the data structure and issues a gameplay message. That gameplay message is picked up by the window that's on screen, the widget that's sitting there. It shows the choices to the player. The player then selects one of the choices, and we do another RPC call back up to the server, where we hand out the loot from the loot box in the inventory manager, and then replicate that new inventory back down to the client and refresh the inventory UI. So starts with the double clicking, RPC call to the server, all real work done on the server, notification to the widget, ask them a question, back to the server, do the rest of the real work on here. So that's how that goes. Now let's take a look at it in game. Okay, so we're in the editor. Let's look at the opening of the loot box and see it in action in two different scenarios. So I'm in our front end map. Of course, I have to authenticate into the data server. Play, start a new game. And let's start by going into our 3v3 match. And let's just pick a character. All right, so we're in a match, and I've already done a bunch of tests, and I've been given a bunch of loot boxes. So I'm just going to go ahead and press I to open my inventory. You can see that I have a bunch of loot boxes. So what we're doing in this video is that when I double click a loot box, that's hover over. But what we're going to do is double click, and we're going to get presented the loot box result window. We're going to have our guaranteed items here, and then our selection items here. And we cannot select yet. We can cancel. Open up a different box. Our items. Let's select our gem and hit select. And you'll see that I lost one of my loot boxes, and I picked up my gem and my coins. So I can merge those two together. And then all the rest of the inventory works. If I wanted to delete that, I could delete it. Get rid of that. And the same rules that apply in our other. If I cannot delete, it goes red. If I cannot drop into the world, it goes red. So I'm stuck with this currency. So I did set the loot boxes to be currencies, so that when I'm filtering through here, loot boxes are found under currency. And again, let's double click another one. And we keep getting the same results. There, we got the premium. So this one, we got the standard 100%. You're going to get this. But I think there was a 20 or 30% probability you were going to get this. And since we're filtered to currencies, we're only seeing these gold coins and premium currency. We remove our filter. You see we have our gem that we've been getting as well. So click another one, select more gems, and we get 3 gems now. So now the stacking isn't working. I will fix that. I just felt it wasn't worth saving the video for me just to fix the stacking. That's just copying code from another project into this one. But there you go. As we open loot boxes, we get presented our choices. We select our choice, and it manifests itself in our inventory. Though these will eventually just stack up and give me the proper counts. Why those didn't merge. All right, so now let's leave the match. And just to show you that if you were building a persistent world, then this is our open world. This may have represented, the 3v3 might represent a portal into an instance where that instance sets up for a 3v3 match, but then you return back to the main world, which is this one. So we're going to launch that server, and we spawn into that server. And if we pull up our inventory, you see that our loot carries from instance to instance, since it's all being stored on the database server and then pulled back up for each match or world that you go in. So whether I'm in this world, and let's destroy 2 of our gems. So we're down to 2 gems. Nope. Let's make sure we still have 2 gems. We have 2 gems. Go back into a brand new 3v3 match. Different character. And if we open our inventory, we'll see that we only have our 2 gems. All right, so that's it in action. Let's go take a look at, let's drill into a little bit deeper into the code. So before we jump right into the blueprint and just start navigating around inside the editor, I thought let's lay a couple of these out in static form so that you don't have to keep scrolling back and forth through the video. So this is the inventory grid that presents the items to the user, the loot boxes, as well as the rest of their inventory. On that, there is a common tile view, which is this view tile widget that has the on item double click event. So you just basically add this on item double click, which means if I double click any of these items, this event will trigger. Sticking in the inventory grid, whose parent is nothing more than a user widget, so there's no special parenting of this widget. We'll see the startup logic when we go into the grid, the refreshing of the grid here. This is for all the different inventory types and the filtering, and then our double click logic here. So our double click logic will basically validate that everything is as it should be. It will present a widget to the user, and then it'll ask the server to perform the probability analysis on it. So when we go into the inventory grid, this is kind of where you'll look at it. The other class is our modal loot choice class. This is parented to the common activatable widget. Same general conceptual visual. The top will be the setup logic that occurs on initialization or activation. Here's the main logic for selecting the loot and making the loot choice. And then here's when we shut down the widget, our deactivation. So this will give you kind of a high level overview when we go into these 2 widgets, which are the primary 2 widgets in the system. When we look at the code, there are 2 primary code blocks. One, the inventory item fragment for the loot box. We've changed this around a little bit, so I'm just putting it here so everyone knows and sees the final version. So you can see the includes that were necessary. We generated a struct that equals one item. So it is an item definition, a stack count, which we still haven't completed, but fine, a stack count, and then a probability of getting it. And so that's one item. Those one items are then placed into two different arrays, one for a select one of list and one for the guaranteed loot list. So everything in the guaranteed loot list is given, plus whatever they pick out of the select one. Those arrays are set up inside of our fragment loot box class. And then we have one more field here, which is a common activatable widget class. So this is so that if we want to have a different visualization, a different pop-up window for different types of loot boxes, we would change the widget class here. So it's overkill if you're only going to have one loot box and only one style. But if you're going to have multiple styles, a fancier one maybe with more particles and more, just to convey the grandness of the chest, you may want to have a different class, and therefore by filling this in here, we can support that. One thing I thought I would insert, since we are talking about the items, is I'm not sure I ever showed the item definition of a loot box. I don't know why it does this sometimes. So the item definition of our loot box is an item that we persist in the database layer. We show it in our inventory, and we're allowed to have more than one of them. The visual identity is this appearance, this inventory icon appearance, which has whether or not we can store it, whether we can delete it, whether we can drop it, what does it look like, what's the border color, etc. We also have our stacks. So when we're doing our stack logic, these stack counts will be what we're going to work with. Second fragment. Then there's our loot box fragment. This is our new fragment. Our new fragment says I have a select one array where I might get a rough gem. In fact, I have a 100% probability of getting a rough gem in the select one loot box. And I have a 100% probability of getting some cooked meat. So these, I'm going to get to pick between a rough gem and cooked meat every time. They're both at 100%. In my guaranteed loot box, I have a 100% probability of getting some gold coins, but only a 20% probability of getting some premium coins. And then when we open it on screen, this is the class that I want. This is the widget class I want to use. So I can change this by different loot boxes. So hopefully that is helpful in this sequence. All right, flipping over to the inventory manager. This is the loot inventory manager component. Same thing, you can see the includes that we needed. We had to create another struct called the loot message. This is what is used for the pop-up or the toaster. We covered this in the other video, part 2, when we did a toaster of a particular piece of loot. We've added the loot choices structure. This is needed for the server to populate what it chose. So the difference between the loot choices and the fragment is the fragment says you have a 10% probability of getting this item. The loot choice structure is the result of whether or not I did get that loot item. So you'll see that when we go through the code. But know that loot choices are two exactly the same arrays, but they'll contain different entries. Then we have our main class definition. This we saw in the other video. They trigger the reward. They basically tell the client we got an award and then throw the toaster up on screen. These first couple are all associated with the first one is opening the loot choices. So let me try to say this again. Once I double click something, these all come into play. So I start the double click by requesting an open loot box. That open loot box then does all of the necessary math on the server, populates this loot choices variable with the results, which triggers this on rep loot choices, this function here. Eventually in that function, the user, this then presents the visual back to the player in the client. When the client selects their reward, this reward choice is called with the reward that they picked. And then only on the server do we give player his guaranteed loot and give the player his selected loot. So those are all new. We're going to see all of those as we go through the code. All right, so hopefully that's a bit of an overview and a place where you can come back and look at stuff. Now let's jump back into the editor and look at the Bluebird class. Okay, back in the editor, let's take a look at some of the classes. Now, some of the stuff may look foreign to you because it's from our prior series where we created our inventory system. I will try to stick to just the deltas here without too much rehashing of that other video. So it starts with, we have an inventory tile. And this inventory tile is not a real, I guess it is a real thing. It is a visualization of what an item looks like. And so if I open this, you'll see that it's a simple user widget. It has a few fields, a rarity border. Let's make this bigger. The rarity border, the main icon, which is in the middle, the embellishment, which is this little scroll in the corner, and then the count, which is this 99. And so what we need to do is when we're adding our loot box, we need a way to populate all these values. The way we do that is very simple. We're using the on list item object set, which is automatically fired based on the way we've set up the parent widget. We cast that to this data object, which gives us access to the item definition and the number of stacks. And then we simply call this set icon from class, which is a function here in this routine. That takes the item definition and makes sure it's valid. If it is valid, we're going to go grab the inventory fragment for the, it's this one here, the inventory icon. We're going to grab the inventory icon. That gives us the icon, the rarity, and the embellishment. And then we're going to set our icon to that, which is basically just taking all the visual elements and making sure they're set to the right size and set to the right brushes. So that was all covered in the inventory system, but know that the way we populate the visuals is through this on list item object set. Okay, so that's it for that lowest level visual. That uses this very simple U object that simply has the item definition and the stacks. So that's all there is in this U object. There's no code. It's just those two variables. We go up one from there to the grid. The grid, which is this tile view widget, which should have populated my details, but it's not. I don't have no details. I think I've crashed. Oh, no, just an extremely long. All right, so the tile view widget, which is the container for these visuals, has here the entry widget class, which is this class here, and then the on item double clicked, which we have enabled. So if I double click that, it's going slow. No, that's what you click. All right. So that brings us to where it is in the code. Now, as a quick refresher, in the inventory grid on startup, we basically do what we need to do, refresh the grid, which pulls all of our core logic into the UI, and then listen for future refreshes, which is this gameplay tag. Whenever that gameplay tag occurs, we refresh again. The refresh, I'm not going to spend a lot of time on it, but it basically loops through all the inventory, makes sure everything is proper and visible, and adds them to the list view. This is what's new. When we double click, like you saw in the video, when we double click a chest, it should always pass this because every piece of inventory is an item instance. That should never fail. We then make sure that whatever we double clicked on has the loot fragment, because if it doesn't have the loot fragment, then double clicking it should do nothing at this point. We could add a branch here if we want to double click other things, but at this point, if it's not valid, we're done. It's not a loot box. But if it is valid, we're going to pull off of it this loot choice widget class. That is the class that we talked about in the C++, where it says if I set a different class here, you can have a different visual. We check that it's valid, and then we basically push that class onto the modal layer of the UI. And so that basically pushes that widget up onto the stack. For safety, we wait one tick, which is really next to nothing, but it allows one more CPU cycle to occur. And then we request the server to open our loot box. The reason we did the one tick delay is I want enough time for this widget to construct itself and start listening for the message before the server sends the message. But at this point, I did the double click. I now request the server to open the loot box. So that's going to trigger the C++ code on the server. In fact, let me just pull that up for you here. It's coming up on another window. Okay. So when we open the loot box, reward choice, one moment. When we request server open loot box, these two functions get called. The first function is a validate, which you're looking for it to return true to continue or false to cancel. If you do return false, it will kick the client from the game. It is considered cheating. So as long as the box that they're opening is a box that I have, I consider that the only real test I can do at this moment. Once this passes, it calls the implement function. I once again check that the item instance is valid, and this is valid on the server. So if I send an item instance up and it doesn't match on the server, then it's not going to do anything. I then check that it has the fragment. Make sure it has the fragment. If I don't have the fragment, I eject out. Here I define my empty loot choices. So I create the empty data structure first. I then give all of the guaranteed loot items at their probability range. So what this is doing right here is saying, give me a float between 0 and 1. And so let's say I got 0.1, 10. Is that less than or equal to the probability float here? And so in order for me to have an 80% probability, then 0.1, 0.2, 0.3, 0.4, 0.5, 7, all the way up to 0.8, every variable below that would pass this test and I would get it. Anything higher than the 80, 81, 82, 83 would fail and I wouldn't get it. So to have an 80% probability, it's 0 to 8. 100% probability is 0 to 1, and everything is 100%, right? If I put a 1 in the probability flag, there's no way I'll generate a number bigger than 1. So that gives us our loop. Then we go through and we establish the select one using the exact same logic. But this time it's the probability that we present the offer to the player. So I might have 5 or 6 things in the select one with different probabilities, and they may only get to choose from 3. We then store the item instance here to represent the item instance that loot choices currently represents. I'm not sure why these are saying they're undefined. So we move our working array. The reason we use a working array is we don't want the server sending partial replications to the client. We want to complete all of our work and then send one delta change to the client, which is what that variable will do. And then for the listen server, of course, we have to call it directly, just like we did in the other video. So that's the way that the server populates this loot choices, which is this loot choices, that will automatically replicate to the client and call the onrep loot choices. So if we just finish that logic a little bit, when the onrep loot choices fires on the client, it is after the data structure has been replicated. So the data structure on the client matches the data structure on the server, and then the onrep is triggered. We get the message subsystem, and we broadcast the appropriate message and passing it the payload of those loot choices. So we broadcast the loot choices on the client to other classes on the client. And that's what presents in the window. So if I go back to here, when I request the server, so this opens the window on screen. This requests the server to fill the window. Then the broadcast occurs. And and this box is sitting here waiting for that message to occur. So the widget was brought up and it's waiting for the server to tell them, okay, this is your payload. This is what you should load onto the screen. Let's go back and take a look at the loot box. So this is not a very fancy widget. I simply fill the screen with a background to kind of block out the rest of the UI. I have some common text boxes, little message that will change depending on my status. Then I have my standard list, which is my common list view. This particular one has no selection mode because I don't need to select one of these. You're going to get them all anyway. And then my choice list is identical, except it has a single select set on it. And when the item is clicked, I have initiated code. So clicking on these do nothing. In fact, they're not selectable and they don't fire any code. Clicking on the select one fires a little piece of code that essentially just unlocks the select button. So when we click that, when we click, we're saving the item we clicked on, and we're enabling the select button at the bottom of the screen. So that when I press the select button at the bottom of the screen, I validate that the list item and the selected items are the same. That's just a double check. All right. I cast that item to that little data structure that we just talked about, this 2 data element data structure. I grab that item definition because that's all I know right now. And I need to convert that into the choice array. So this was the only little tricky stuff. Since I need to tell the server which array element I want, then I need to be able to get that based on the item definition. And so when we received a payload through this message, we went ahead and saved the select one array to a local variable. And here you see the set message for waiting for server to respond, or please select your choice, which populate in this message spot. But we save this selectable item array so that when we're down here and we need the index, we do a very simple and very common pattern. We take the item definition as an input. We set our working index as -1, indicating not found in the array. Then we search that saved item array, break the elements, and check the item definitions to see if they match. As soon as they match, that's the index, and I can break out of this loop and return that index back. So this little pure function is dependent upon this array being populated from the message, so that it can perform that activity. Okay. So we've selected, we've checked it, we've gotten our index number, and we're going to ask the server, okay, I would like this particular reward. I want number 2 or number 3 or number 4, whichever reward I selected. Then we wait and then deactivate the pop-up window and tell the inventory to refresh. Doesn't matter what this is. Just tell the inventory to refresh the standard view. So this request server reward choice we're going to validate that the index that was passed to us is actually in the server version of that array. So we want to make sure the server version now has that same index. And then we do the same kind of check. We check that our loot choice instant is valid, so that we don't double open things. We give the player their loot, we give them their selected loot, and then we remove our loot box. So we remove the item instance, so the loot box gets removed from the inventory system, and we null out these 2 working variables so that they're clearing away for the next one. Those last 2 routines are very simple. To give the player the guaranteed loop, we just loop through and give them everything that's in the loot choices. Remember, we randomized it and picked it from probabilities earlier. That's what populated this loot choices. And then the selected one, we simply give the selected index. So we take the index and we say, okay, you're going to get that one. And that's the item definition you get. And that's pretty much it. I think if I missed anything, so in the pop-up, we listen for the loot choice. We disable the select button until such a time as the loot information is sent from the server. We save the array off. We update the message on the screen. These are just 2. These are pretty simple. They're identical. They basically add the choice loot. So I take the array, I clear my on-screen list, I clear it, and then I loop through that array, construct this object, because the array needs objects. That's the data object. So you would just do a construct object from class, and then as soon as you pick the item icon, the item icon class, these were exposed on spawn. So I forgot to mention that. Those are exposed on spawn, so that when we take this payload, we can just populate it into this class and then add that class to the list. Right? And so when you add the class to the list, when you add that to the list, this code is triggered, which takes that object and casts it back to this B item icon object, which is this here, right? same class, so that in here I can then pull my item definition and format my visuals. So three classes. Hopefully I explained that fairly well. Just to see it one more time. I think I did. This is the inventory grid. When I double click my loot box, the window's popped up and you receive your loot choices. You cannot select till you make a choice, then you can select. Window is closed and loot is given. All right, so I think that's it. I may put together one short video just as a sizzle reel across the whole thing. And then if I have any bugs or fixes or any questions in the comment area, we'll work on those. But this should wrap up this series. Hope you guys have enjoyed it. As usual, it was a bit more of an undertaking than I thought when I launched it, but I'm glad we got through it. Thanks for watching the series. Leave a like or subscribe, and have a great day.